All right, this is going to be the Calculus 2 portion of the notes where we're starting this and going a lot faster. Secant, right? M secant means slope of the secant, right? Okay. So, using the process, M tangent means it's the slope of the tangent, right? At that point, we know that we're looking for the slope of the line at the point of the function, okay? It's actually not the equation of the line like the red one. It's not the equation, it's just the slope at that point, okay? So you would have to do a equation of a line to actually figure out that given the slope. So you'd have to do like point slope formula. Okay, so I'm going from there. So commonly referred to as L. When we're doing the limit process, it will be referred to as L, and that's going to be the limit as x approaches c of f of x of my function is going to be L. Okay, so the value of fx can be made as close as we please to L for significantly close to c but not equal to c. Now, whenever I'm doing this, if I go back, if it's equal to c, what would happen over here? It'd be what? Undefined, right? Because you'd get 0 in the denominator. Okay. What is this saying? -2? Is that what you said? Okay, I thought I heard -1 there for a second.
No, as x becomes negative.
Okay, so as the limit of f of x, I'm sorry, the limit as x approaches -1, the limit is equal to -2. The limit of the function right here. Can I plug in -1 into that function? ¿Por qué? Undefined, right? So it's going to be 1 again with that little hole. Okay, it'd be an open dot on that point right there. All right, investigate right here. So using a table, okay, how would I go through and do this? So now I'm going to do it once for you guys, and then you guys are going to be able to do it yourself after this. All right, so something special about these calculators. I'm going to show you how to do it now. So let's take a look at this one. Okay, actually, I want to use this problem. Nope, that one. Okay, so go take a look at your calculator. So I'm going to bring up the calculator app right here. Okay, so home, scratchpad. So I don't want this scratchpad yet. I want graph scratchpad. So here's my graph scratchpad. So I'm going to put in my function right there. My function was what? 2x plus 5. There we go. Enter. So I get my function there, right? So is it right there? Can I? Because I'm looking at 2, isn't it? I'm looking for 2. So now, since if you notice it doesn't fit right here. Now, if you notice, I'm going like this, but you could use this scroll pad right here on your thing. So I'm going to grab it here, slide it over a little bit, just to shrink it so I know that I'll have 2 on my graph. All right? So it doesn't have to happen just so if you want to see it on your graph. Because it looks like right here, hey, it's going to be right there. That's going to happen. Okay? So, now from here, this is my F1 function. Now we're going to go to scratchpad again. This is my regular scratchpad. Okay? Is everyone there? Okay, so now we're going to do vars. This button right here is vars. And there's my first function, my F1. So you could do this with multiple functions too, especially it helps out a lot, okay, as we go with this to multiple things. Anyway, so I have F1, so I have it open up. So what was my first number on the left to enter?
1.99.
So 1.9? 99, 2 nines?
Yes.
Okay, hit enter. There we go. Okay, so I can go through and do this consistently, just keep changing my f. So f of, what was the next one? 1.999. There we go. And it keeps going. So I gotta change this. Document settings. I need radian. Okay. All right. So let's see, as I go, this is going to be 1.99, so it gives me, what was it, 8 point what?
90.
Next one's going to be 8.998. Next one's going to be 8.99898, right? Skip this one, that's kind of cheating right here, so it's missing the point. All right, so on the right-hand side, what are we going to get?
9.02.
9.02. Next one? 0.002 and 9.0002. Now, make a guess, make an inference. What are you saying this is going to be? It's going to be 9, right? This one's going to be easy, so this is 9. So it doesn't always approach. Now, you guys have done this before. What has to happen for the limit to exist?
There has to be a right side and a left side.
Left and right both have to go to the same number, right?
Yeah.
Okay. So both left and right have to go to the same number. So let's see. All right. There. Okay, left hand, right hand. Notation for this. We have the positive here for the left hand. Or I'm sorry, negative for the left hand and positive for the right hand. So your plus and minus approaches it from left and right. So we could do one-sided limits also. Okay, now for this one right here, I'll let you guys work on this later. This is going to be, guys, for you, so put a star on this. Okay, investigating a limit using a table and technology. So this one right here, again, it's the exact same thing. So what has to happen to do this problem right here? It's really important. It's one of the things that would have screwed up your entire AP exam. Got to be in radians. So take a look at your calculator, please. Make sure it is in radians. I had to change some people this morning. Okay? So this one's going to be for you. Now, if you notice, since you have to build your own table, what should happen somewhere in the middle here? That should be at 0, right? So you guys are going to fill out your own numbers for this. Okay, so star this one also. You guys are going to come back for this one. Investigate a limit using a graph. The graphical function can also help us investigate limits. Figure 11 shows the graph of 3 different functions. Okay, so I think, is this one I have to actually click on? Okay. Is this figure 11? Oh, here it is. Yes, this is it. Okay, here's A, B, and C. All right, so again, this one right here, if you guys can see this. So I have my function, which is the blue line. I have the blue line right here. So my function, my left side and right side are both going to the same number. Is there any holes? Is there any jumps? Is there any skips? Is there anything I have to worry about? No? Okay. Is it at that point? Okay. The function exists at that point, right?
Yeah.
Okay, that's good. Okay, let's look at the next one. So that's where the function's equal to the limit. Now, G, right here, it says the function's not equal to the limit. Okay, so G of C is not equal to the L. That means for my G, which is my blue line here, so there is a hole there. That means that open dot means the function does not exist at that point, but both left and right hand sides go to that point, right? Okay, very good. And so this one right here, this is H of C is not defined. Okay, so this right here, both sides going to it, and this one, for whatever reason, it is not defined at that point. So it's just saying, you know, it's the function is not there. Okay, so suggests that the limit of function as x approaches c depends on the value, if it exists, of the function at c. All right. Investigate a limit using a graph. So now, use a graph to investigate this limit right here. So limit as x approaches 0 of f of x if f of x, here's my piecewise here. Okay, do you guys know how to enter piecewise in the calculator?
Yeah.
Okay, so let's try that. Write me out. Go to tab, go to up, and then right here. So what would I do to enter a piecewise?
When you hover one next to it.
Okay, good. All right, so this piecewise has 2, right?
Yeah.
Okay, there we go. All right, so now my piecewise was what? 3x plus what? 1. Okay. And where x is? Not equal to? 2. And then go to the bottom part. It's going to be what? 10.
X equals 2.
Okay, so x equals 2. Here's my piecewise. Enter. All right, so now if I look right here, so let's take a look at my thing right here. There you go. So when x is not 2, I get this function right here. So let's see. So when it is 2, I get 10. For everything else, it's this. So if I'm looking at right here at 2, all right, let's try a trace. Let's do a trace here. Menu, trace, trace graph, and let's see. All right, so I'll follow it over. So if you notice, look at my values there, 6.4. On the other side too, oh, what happened right there? Oh, I can't click on it. So let's figure out what it's going to be. So I'm just going to hit the number 2, hit enter. It goes up to a spot right there, doesn't it? There we go. I know. Ooh, ah, it's sparkly. Anyway, so there we go. So it only exists here. So now, what would I say that the limit of that function is? Okay, so for this one right here, does it matter that x is approaching 0 and right here I got issues with 2? No, the 2 doesn't matter at all, does it?
No.
No, but that's the part right here. So the 2 doesn't matter because I'm only checking when it approaches 0. So at 0, what's my answer? 1. Okay. Where'd my graph go? Lost my graph. There it is. So it's going to be 1 at 0. That's all I'm looking for. Dang it. Keep losing it. Okay. Okay. We just did that. Okay. Use graph to investigate the limit of this. Okay, so it's going to ask you left-hand side, right-hand side, and then you're going to tell me what it comes to in the middle. Okay, star that one. Okay, right here, here's the notes for this. So a limit, okay, as x approaches c is a limit if and only if the left hand is equal to the right hand. That's only if the limit exists, if the left hand equals the right hand. Okay, investigate here, star this one. So it's asking you, what is it going to be at 1? What is it going to be at the left of 1? What is it going to be at the right of 1? Okay. So, did I say star that one? Yeah, star that one. Use a graph to investigate this one right here. So we throw this in the handy dandy graph, and then you have to look at the graph Or what else could I use if I can't tell from the graph? Table.
Oh, that's your.
Oh, I'm sorry. Table, right? Sorry. I would use a table, right? I would approach it from both sides using a table to see what it gets, right? Okay, so star that one. Okay, now we should have done these before last year. Okay, what's going to happen on this? Okay, what is this one going to do?
Doesn't it keep going? Oscillate.
There we go, that's the word, it's oscillating, right? It's oscillating. So as you keep getting closer and closer, all it is keep doing the same thing over and over again. Okay? So you can keep getting closer and your graph is just going to be a hot mess like this. Okay? Oscillating. Okay. Here's your stars. Here. Your practice problem there. 2, 3, 4, 5, 6, 7, 8.